The following is an exclusive and confidential preview of the Logic Interface Network, or LINK. LINK is the future of integrated multi-facility logistics operations. Together with Logic Pallets, they form a combined solution to accelerate the development of micro-fulfillment centers connected across a fully automated supply chain. The LINK is a cloud-based warehouse operating system orchestrating intra and inter warehouse tasks executed by the world's first multi-facility robots, Logic Pallets. From this dashboard, the user can access, monitor, and control any Logic-enabled facility in their network in real time. Let's begin by taking a tour of LINK's warehouse management system by selecting a facility. The main screen brings up the zone dashboard. This view shows a floor plan of the entire facility, detailing what's occurring in each zone. Zones 1 through 5 and 11 through 15 are active zones, which contain loading, interaction, and short-term storage areas. Zones 6 through 10 are passive zones for long-term storage. The left toolbar allows the user to select different warehouse operations, while the right toolbar shows the mission planner, an interactive schedule of Logic Pallet activity. At the top right is the notifications window. This alerts the user of manual tasks that need to be completed or allows them to monitor automated activities in real time. Let's focus in on Zone 2. Selecting a zone brings the cell dashboard to the main screen for a closer view of the areas within that zone. The key shows the designated uses in each cell. There are 4 areas within an active zone. Starting at the top, the first area is the docks. Dock 4 contains an empty truck, Dock 5 is unoccupied, and Dock 6 contains a full truck. Second, the loading area, which consists of loading cells used to move Logic Pallets on and off vehicles, and staging cells used to inspect inbound and outbound Logic Pallets. Third, the interaction area, which consists of picking cells where robotic arms or humans move items between Logic Pallets, interaction cells that Logic Pallets occupy while the picking occurs, and circulation cells that allow Logic Pallets to move rapidly between zones. Finally, at the bottom of the screen is the aisleless storage area, where Logic Pallets are stored. Logic Pallets loaded with items are shown in light blue, while empty Logic Pallets are shown in white. Let's select a Logic Pallet and inspect its inventory. Here, we see a single item Logic Pallet of toothbrushes. This is typically how goods are delivered from a manufacturing facility to a distribution center. If we want to find a specific item anywhere in the stack, we can select it from the inventory list on the right-hand side of the main screen. The Logic Pallet avatar on the left side of the main screen highlights the selected item's position in the stack, while the right side shows item details, including the item code, expiration date, count, and color. It also contains information on carton dimensions and strength rating, which allows the LINK to optimize item stacking configurations. A transfer order is requesting items in Warehouse 77 to be moved to Warehouse 27. The LINK has already sent the outbound Logic Pallets to the staging cells and completed the scanning protocol. An empty truck is at the dock ready to transport the Logic Pallets, which generates an outbound notification. The user approves the Logic Pallets to load on the truck and depart the facility. LINK's transportation management system tracks Logic Pallets in real time as they travel between facilities. Users can access the location, weight, and temperature data of their items in transit. The LINK's onboard GPS provides its users with better monitoring and arrival estimates than most industry-leading transportation management systems. We will now move to Warehouse 27 and await the inbound transfer. An Advanced Shipping Notice, or ASN, tells a facility when another facility is sending them items, typically in response to a purchase order. This is an opportunity for the inbound facility to accept the order or request changes before the order leaves the outbound facility. It is now the next day, and we've received the notification that our order has arrived. The LINK selects the zone it wants the arriving order to be stored in by predicting how the arriving items will mix with other items in that zone based on future outbound orders. The link assigns Zone 3, loading dock 9. Detecting that that dock is clear, the user approves the unload. The logic pallets unload themselves through the loading cells and move to the staging cells where they await inspection. Arriving logic pallets are inspected for missing or damaged items. Logic pallets' integrated weight sensing will detect any activity prior to arrival, vastly reducing inspection time, which increases the daily vehicles per dock. As you can see, there were no recorded weight changes in transit. The link asks the user to confirm the load by scanning the stack with the camera of their mobile device. Once the logic pallet is scanned, the user can permit the put away. The logic pallet moves to the storage area. The link's algorithm selects its storage position based on when it will be needed next, minimizing overall movements, power consumption, and the movements of other logic pallets. As you watch the logic pallet approach the storage area, notice the format of the warehouse is already optimized for micro-fulfillment centers. In manual warehouses, the process of loading a standard pallet on a forklift, transporting from the inspection area to the storage area, and unloading it takes on average 10 minutes. We just saw a logic pallet do that in less than 30 seconds. That's a 20x improvement. A store has placed an order which prompts the link to build logic pallets with mixed items to fulfill it. This is a partial list of items to go on the first empty logic pallet. The link has grouped these items together based on several factors, including size, weight, common shipping requirements, and associations at the receiving facility, such as aisle location in a retail store. The link finds an available picker in Zone 3 to build the mixed pallet and schedules the missions. The link identifies the empty and loaded logic pallets needed to build the mixed logic pallet and configures it to optimize load balance. To achieve this, single-item logic pallets are brought to the picking area in the order in which their items need to be restacked on the mixed logic pallet. Let's watch the link move these logic pallets to the picking area in 3D view. What you are seeing is Link's virtual warehouse simulating real-time activity. Designed for remote warehouse management and future AR or VR control, Link's 3D view allows the warehouse manager to see what is happening in the warehouse as if they were there. From this view, you can really understand the impact of the aisle-less storage, which increases warehouse density by 3x. For this demonstration, we have added in some footage of a real logic pallet navigated by Link through various environments in our test facility at Wentworth Institute of Technology. In facilities where the picker is a robotic arm, this process will occur without human interaction. So let's take a look at what a human picker will see. The link instructs the picker to move the box highlighted in green from the single item's logic pallet on the left to the position indicated on the mixed logic pallet on the right. Notice the product count, weight, and weight change at the top of the picking dashboard on the main screen. These values change as items move from one logic pallet to another. The sensed weight and weight position changes confirm the movements have been done correctly. Once the item moves are complete, the link will bring up a review screen where the picker can confirm their work and allow the logic pallets to move to a different area. As the first single item logic pallet returns to storage, the logic pallet carrying the next item in the stack makes its way to the picking area. In fully automated facilities, denser interaction cell occupation will be permitted, cutting already shortened pick times in half. As these items are picked, let's view the Link light mode. You can see Dock 7 has almost a full truckload ready to depart. When the full order is ready to be shipped, the Link assigns an outbound dock, and the mixed logic pallets make their way to the assigned staging cells for outbound inspection. Every year, about 7 million trees are harvested for the production of approximately 500 million new wooden pallets in the US alone. Most of them are discarded after a single use. Multi-facility logic pallets are reused throughout the supply chain thousands of times. The user scans the outbound logic pallets and permits them to leave the facility. The Logic pallets load themselves on the truck. Automated loading and unloading will play a major factor in deriving the maximum efficiency from driverless vehicles. Link is modernizing logistics software to operate the warehouse of tomorrow. It is the only integrated multi-facility transportation, warehouse, and automation management system, and it's built from the ground up on the world's first multi-facility mobile robot. We look forward to showing you how Logic can decrease cost, time, space, and carbon footprint in your supply chain operation.